In this video, let's see problems in probability distribution. Whatever we have learned so far, what are the types? Binomial, Poisson, exponential and normal. Of course, random variable in discrete and continuous. So, once if you read the problem, just pause the video for a second, try to answer it on your own and then continue the video. Okay. So, let's see the first problem. The PDF of a variable x, that is the probability density function of a variable x, is given. So this is x, this is the corresponding probability. Find k. If this represents the probability distribution, also find p of 3 less than x less than or equal to 6. The moment you see the tabular column, first of all we have to fix it, whether it's discrete or continuous. For each value there is a corresponding value of k, so it is discrete. If it's a continuous, means they will give in the interval. Okay, fine. So this is a discrete random variable. Now second thing, once if it's a discrete random variable, what are the condition? Each probability should be greater than 0 and their summation should be equal to 1. So these are the two properties of a probability density function. So what I'm going to do, I'm going to add all these value and I'm going to equate it to 1 so that I can find k. So k plus 3k plus 5k plus 7k plus 9k plus 11k plus 13k, which is equal to 1. So 49k is equal to 1. So k is equal to 1 by 49. Now they have given the probability. What we have to find? 3 strictly less than x less than or equal to 6. So 3 is not included. After 3, probability of 4, 5, here 6 is included because less than or equal to. Probability of 6. So what are the probabilities of 4? 9k plus 11k plus 13k. These are the probabilities and we know what is k. K is 1 by 49. So this is a problem in random variable of discrete type. Now, this is the next problem. Given f of x is equal to 0 for x less than or equal to 0. So for negative values, there is no function. Function value is 0. And kx e power minus 4x square for x greater than 0. What is your question? Find k. And also find the probability of, say, 0 less than x less than 8 and probability of 3 less than x less than 5. So you can pause the video, try to solve it on your own. And now what are the condition? Each probability should be greater than 0 and their summation should be 1. We saw the discrete version in the previous problem. Now it is a continuous version because they've given an interval. So now you can identify what is a discrete version and a continuous version. So in continuous version, the summation is nothing but integration. So minus infinity to infinity, f of x is 1. But my function is valid only for x greater than 0. So this minus infinity to infinity will become 0 to infinity for this problem. Because for this problem, my function exists only when x is greater than 0. So I am writing integral 0 to infinity, this function dx is equal to 1. Okay. So here integration by substitution, this 4x square, e power whatever junk is there, make it as t. 4x square as t. So 8x dx will become dt. And when x is 0, t is 0. When x is infinity, t is infinity. So the limit doesn't change. So integral 0 to infinity, k, in the place of x, I am substituting the value. Okay. What is x here? X dx. This x and this dx together is 1 by 8 dt. dt by 8. So k is there as it is, e power minus t. So k by 8 is a constant, e power minus t if you integrate, minus e power minus t. 0 to infinity is the limit. What is the upper limit? E power minus infinity, 0, minus lower limit is e power 0. E power 0 is 1. So already 1 minus is there and lower limit minus, so it will become plus. So k by 8 is equal to 1, therefore k is equal to 8. Okay. Yeah, I have written the same integration over here. Upper limit is e power minus infinity 0 minus e power 0, that is minus 1. So this minus and this minus will become plus. So k by 8 into 1 is equal to 1, therefore k is equal to 8. If they ask this from 0 to 8, because my function is valid for x greater than 0. So integral 0 to 8, same integration is the same, only whatever limit you are applying, this will, I will write 0 to 8, that's it. Again, p of 3 less than x less than 5. Integration is the same. And what is the limit you will apply? 3 and 5. Upper limit is 5 and lower limit is 3. Upper limit minus lower limit. Question problem is the same. So we have learned two problems, that is finding k and finding the probability in discrete version as well as in continuous version. Now I'll throw some random problem. Once you see the problem, you fix what type of problem it is, whether it's a binomial, Poisson or exponential or normal. In the last video we have seen many problems in normal distribution. So first you read the problem and fix the probability distribution. Yes, now I'll hide the answer and I'll read the question. The probabilities of a Poisson taking the values 3 and 4 are equal. What is the clue here? Poisson. So you got that it's something related to Poisson distribution. Okay. This problem is slightly different. Calculate the probabilities of the variate taking the value as 1. Okay. How to start with the problem? Just pause this video for a second. Try to solve it on your own. And now. So it's a Poisson distribution. What is the formula for the Poisson distribution? P of x is equal to e power minus m power x by x factorial. What is the clue they have given? Probability of 3 and 4 are equal. That is p of 3 is equal to p of 4. Replace x by 3. E power minus m power 3 by 3 factorial is equal to e power minus m power 4 by 4 factorial. E power minus m will get cancelled. M cube and m power 4. Only one m will be left, correct? So 6m is equal to, it will get cancelled. 6m is equal to 24, m is equal to 4. So you got what is m. So what is the formula for probability? E power minus m power x by x factorial. You have replaced m by 4. Now what is the question? Then you can answer anything easily. Calculate the probability of the variate taking the value as 1. So I'll write replace x by 1, p of 1. This is the probability we have to find. Simple. So this question is a Poisson variate, and of course this question is slightly different from the usual question. And now the next question. A shop has 4 generators which it hires every day. The demand for a set is a Poisson variate. Now you got the clue? It's a Poisson problem. With value 5 by 2. Okay. So obtain the probability that on a particular day, question 1 is there was no demand. Question 2, demand had to be refused. Now you can pause the video, try to solve it on your own. Hope you might have solved this problem. So this is the explanation. Average demand they have given. So it means average in Poisson distribution is nothing but m. So m is equal to 5 by 2. If you write it in decimals, 2.5. This is the formula, e power minus m power x by x factorial. So replace m by 2.5. So you got this. Now what is the first question? There is no demand. When there is a no demand means then it is p of x is equal to 0. So wherever x is there, substitute 0. Anything power 0, 1, 0 factorial 1. So what you will get? E power minus 2.5. Simple. And the next one is demand has to be refused. When they will say that we cannot hire you a generator set, because already they are having 4. When they can say that no, we cannot give. When the demand is more than 4. Correct? You are having 4 chocolates in your hand. Of course, you pretend that you won't eat that and you will give it to others. So when you will say that I don't have chocolates in my hand, I cannot give you one. When you have distributed all the 4 to others, and so the 5th person is coming and asking you that I need a chocolate, then you will say no, I don't have one. So when the demand is more than 4, so p of x greater than 4. So this is nothing but it's like 6th person, 7th person, 8th person, 100th person if they come and ask you also, at that time your situation is the same. You already had 4 and you have given all the 4 to someone else. So in that case you cannot keep on writing. So p of x greater than 4 is nothing but 1 minus p of x less than 4. So 1 minus x less than 4 means 0 plus 1 plus 2 plus 3, because you had 0 generator and 1, 2, 3. After that you cannot give. So it is a contradiction. Total probability is 1. So you are subtracting from the total. So 1 minus e power 2.5 is common, right? e power minus 2.5, correct? And then you're writing all the other probabilities inside and you're calculating the value. Okay, so this is the answer for this question. Now, next question. The length of a telephone conversation has been an exponential distribution. Where is the clue? They've given exponential. And found on an average to be 5 minutes. Find the probability that a random call, first question, ends less than 5 minutes. Second question, between 5 and 10 minutes. Again, you have to pause the video and try to solve it on your own. Because all the probability problems, you'll find it very easy when someone is explaining. But when you're solving it on your own, you'll be getting so many doubts. So try to solve it on your own. Yes. So now it's an exponential distribution. Then immediately write down the formula for exponential distribution. That is alpha e power minus alpha x for x greater than 0 or 0 otherwise. I didn't write 0 otherwise because my function exists only for x greater than 0. So what is the formula for mean in exponential distribution? Mean is 1 by alpha. Okay. But in the question, if you remember, found on an average to be 5 minutes. So mean, that is the average, is 5. So 5 is equal to 1 by alpha. Therefore, alpha is equal to 1 by 5. If you remember that, the normal common mistake what you do is you'll take alpha as 5. So mean in exponential distribution is 1 by alpha. So 1 by alpha is 5. Alpha is 1 by 5. So you're going to replace alpha in the formula. So 1 by 5 e power minus alpha is 1 by 5, right? 1 by 5 into x. So minus x by 5. This is your probability density function. Of course, your x should be greater than 0. So what is the first question? What is the probability that a random call ends less than 5 minutes? Okay. Length ends less than 5 minutes means you won't get a negative value because my probability starts for x greater than 0. So 0 to 5 minutes. It can end at any time, 0 to 5 minutes. So integral 0 to 5. Your function, of course, you have to write dx. I must write that. So 1 by 5 is just a constant. Throw it outside. All the integration exponential distribution is very easy because what is the formula? Integral e power something mx is e power mx by m. That's it. So e power minus x by 5 by minus 1 by 5 because the constant is minus 1 by 5 here. This and this will get cancelled. If you want, you can throw the minus outside. E power minus x by 5, 0 to 5. If you substitute upper limit, 5 by 5 will get cancelled 1. So e power minus 1 minus e power 0, you are writing. E power 0 is 1. This minus and this minus will become plus. So 1 minus e power minus 1, I can write it as 1 by e. You can plug in the values in the calculator and get this answer. And the second probability, what was the question? Between 5 and 10 minutes. What is the probability that the call will end between 5 and 10 minutes? Integral 5 to 10. That's it. Integration is the same. Only applying limit, values will change. That's it. There is nothing big in the integration part. So all exponential distribution problems, integration, don't get scared. A normal distribution problem, we won't integrate. If you remember, if you go through the last video, we'll just substitute z is equal to x minus mu by sigma and we'll standardize that and we'll refer the tabular column. Yeah. Now this is the next question. 4 coins are tossed 100 times. Again, this is a slightly different question from the regular one. And it is a university question. And the following results we got: fit a binomial distribution for the data and calculate theoretical frequencies. So they are asking us to fit a binomial distribution, and theoretical frequency is something new. These type of problems will come in both binomial and Poisson. Okay, but here they have given a clue that it's a binomial distribution because you don't know the probability. When we'll distinguish between a binomial and a Poisson, when the probability is too small, correct? So we don't even know what is the probability. Of course, after finding the probability, you can guess whether it's going to be a binomial or a Poisson. So sometimes they won't give the clue also. So number of heads, 5 times you got 0 heads, it seems. So they are, just imagine, they are simultaneously tossing 4 coins 100 times. I think now you can try in this quarantine period. So and they observed that 0 heads 5 times it came, it seems, 1 head 29 times, 2 head 36 times, 3 head 25 times, and 4 head 5 times. So why these numbers means, so just they are tossing the coin and they're getting that result in that game. That's it. So here x denotes a number of heads because we are talking about um, number of heads only. So x denotes a number of heads and f is a corresponding frequency. And how to find the mean mu? If it's a frequency distribution, this is a general formula, summation fx by summation f. So 0 into 5 0 plus 29 into 1 29 plus 36 into 2 plus 25 into 3 plus 5 into 4. I have written all these things divided by this frequency 5 plus 29 plus 36 plus 25 plus 5. Just this is a general formula in any statistical table. This is the way you find the mean mu. So I simplified it and I got the mean as 1.96. Since they have given that it's a binomial distribution, I am writing mean mu is equal to NP. Even for Poisson, we can use this formula because Poisson is an extension of binomial only. Mean mu is equal to NP. How many coins we are tossing? 4 coins. Don't write 100 here. We are tossing only 4 coins, but we are repeating it 100 times. So n is equal to 4 here. So here you have to be careful. Don't make a mistake. So n is equal to 4. Substitute here. 4p is equal to 1.96. We got the probability. If you see the probability 0.5. Correct, 0.49 is close to 0.5. The probability is not too small. So you can fix that it's a binomial distribution. So in binomial distribution, q is always 1 minus p because p plus q is 1. So q is 1 minus p, 1 minus 0.49, that's equal to 0.51. So once you got this value, you are writing the binomial distribution formula ncx p power x q power n minus x. That is 4cx 0.49 power x 0.51 power 4 minus x. Now we have to calculate theoretical frequencies, they said, right? This is very simple. Since we are tossing 100 times, theoretical frequency is 100 into p of x. That is 100 into, you are writing all this probability. So coming back to our theoretical frequencies, what are the values of x? 0 head, 1 head, 2 head, 3 head, maximum 4 head we will get. Because we are talking about getting number of heads. Since we are tossing 4 coins, maximum probability is either 0 head, or in 1 coin you will get head, or 2 coins will get head, 3 coins will get head, or all the 4 coins will become head. So already we have written 100 into that probability. Just you have to replace the value of x in the problem formula and then find out the value. And when you are writing, you have to approximate it, because 25.99 times you cannot say. 25.9 is almost equal to 26. So 26 times you may get 1 head. Like that we are guessing it. So if you add all the values, it will become 100. So that is a good way to find out whether your calculation is right or wrong. So we got the theoretical frequency. Coming back to the next question. In sampling, this is the next question. In sampling a large number of parts manufactured by a company, mean defective of a sample of 20 is 2. In a sample of 20, the defective is 2. Okay. Out of 1000 such samples, how many would be expected to contain at least 3 defective parts? Okay. Now, again you can pause the problem and find out which type of distribution it is. Because they didn't give any clue. Yep. Now if you see, getting defective. In binomial you have only 2 options. Either it should be defective or it is not defective. Only 2 options. So since we have 2 options, we are deciding that it's a binomial distribution. So mean mu is equal to NP. Mean, that is average, is 2. That is NP is 2. So what is N here? In a sample of 20. In sample of 20, average 2 will be defective. So NP is equal to 2 and N is 20. Don't write 1000 because this is out of 1000 such samples. For one sample, this is the case. So finally you will multiply with 1000, but N is not 1000 here. Okay. So 2p is equal to 2, therefore p is equal to 1 by 10, 0.1. So in binomial, what is q? 1 minus p. 1 minus 0.1, so you got 0.9. What is p of x? Ncx, this is the formula for binomial. Ncx p power x q power n minus 6. N is 20, 20 cx, 0.1 power x, 0.9 power 20 minus x. That's it. So now your question is at least 3. So get at least 3 means it could be even more than 3. So probability of 3, 4, 5 till 20. Till 20 it's tough to write. So whenever this is very big, what you can do? Do the reverse part of it. So from the total, if I subtract till 2, you will get this. Correct? So for example, you got 40 marks in the exam out of 100. And if they're asking you what is the marks last, that you won't count 1, 2, 3 till 60. Because it's easy for you. From the total, if you subtract 40, you'll get 60. So total probability is 1 minus whatever which is left. What is left here? 0, 1, 2. This will give you this summation. So we got 0.323. So this is for one such sample. Therefore, for 1000 sample, 1000 into 0.323, that's equal to 323. This is not visible, just we are multiplying it by 1000. So practice more problems in probability distribution. So your challenge is, if it's not given, you have to identify. So binomial, how do you identify? Only 2 choices are there. This is your example. And Poisson also only 2 choices are there, but the probability will be very low. Here it is 0.1, no. So in Poisson it will be 0.001, like that, 0.005. So the probability will, if it's very small, you'll go for Poisson. But mean mu is almost same for binomial and Poisson. So even if you do it by any method, you'll get the correct answer. And in normal distribution, of course, they will mention it. And in exponential distribution also, they will mention it. So only your challenge is to find whether it's a binomial or Poisson. That's it. Thank you.